regression in detail. Okay, so today we will discuss about the regression in brief, because there will be a dedicated session of the regression where we will run the regression models on a Python and we will see that how it works. Okay, so what is regression? So regression is again comes under the supervised learning. If you remember, we talked yesterday. Classification is also comes under the supervised learning. Regression is also under the supervised learning. But what is the difference? Classification is applicable when your outcome is discrete or we have a bounded output. But regression is applicable when you have an unbounded output. Okay, so there is no specific range, or there is a value can be a 50, or maybe it can be 100, or it can be 1,000 or 1,000. Okay, so at that time we will use a regression kind of supervised learning. Now, what is the regression? So as per the Wikipedia, the definition of the regression is like this: that it is a statistical modeling technique, okay, where you estimate the relationship between a dependent variable. So dependent variable is the variable to which you want to predict, okay, and that value of the dependent variable is basically depending on some sort of independent variable. Now that independent variable can be a single or it can be a multiple. Okay, so yesterday only we talk about that if I want to purchase or if I want to sell a house, okay, and the price of the house is depending upon where it is being located, what is the size of the house, what is the construction time of the house. So depending upon this variable, I can predict that what is the price of the house. Okay. Now, regression is nothing but a curve fitting. Okay, so where you have a data point, now you need to draw a line clearly where all the data point could be in a line. So there could be a various method. Okay, it is something like that. That I will draw a line like this. So this is the one solution. But here, what I want, that data point should be on the line. But here, possibly this is the model is okay enough because 4 are basically touching the line, but 2 are considered as the outline. So there could be another solution where I can covering the 5 points, data points, but 1 is still remaining. This is the third one. Okay, so blue line is the best one where I would have all the points on the line. Okay, now again, when I construct a model in a regression, then my intention is I need to put the data point on the line. While in a classification, what was my intention? I need to draw a line such a way that the data point should be at a distance from a line, because I want to classify them in a correctly. Okay, so in a classification, data point should be away from the line, but here in a regression, when I create a model, the data point should be on the line. Okay, so that is the difference that we have. So all these regression models are there: linear regression, polynomial regression, support vector regression is there. Depending upon the support vector machine, classifier is also there. So there is the support vector regression is there. Decision tree is also there in a regression type. Random forest is also there. Reach is there. Lasso is there. Logistic is there. So all these regression models are there. Okay. As I said that maybe day after tomorrow, I think on the day 4th day, there is a one lecture for a regression model. Okay, so Dr. Pratik Jain will take out an example and he will explain you that how you can construct the regression model in a Python script. Okay, now another is unsupervised learning. So we have talked about the supervised learning where classification and regression is there. Unsupervised learning. Okay, now what is the unsupervised learning? Here in unsupervised learning, we don't have a label out. Okay, while in a supervised learning, we have a data, we have an output, that is we consider as a label, and through which we train the model. Okay, here there is no training because we don't have a label out. How we can train? Okay, so in an unsupervised learning, there is no desired output, but we try to identify some relationship inside the data. Okay, so some example is that I have photos and I want to put them in a 20 group. Okay, so it is something like that photo I have. I want to put the photo. Maybe I have one folder with the friends, one folder of the family, one folder of myself. Okay, so I will put the photo in a particular folder. according to whom I have clicked with. So if it is a family trip, definitely I put all those photos in the family. If I go to a friend, then possibly whatever the photo is being captured at the friend. If I have gone to a solo trip, then possibly I will put the one different folder where all the photos are there. Now, when I will go next time with my family, then definitely whatever the photo that I will click, I will put that in a family folder. Okay. So this way I will observe the characteristic or a relationship, and according to that I will take a decision. See, nobody has told me that I need to create this many folder while there is a one folder of the family, there is a one folder of the friend, there is another folder of the solo. This I have decided, and I will stick to that. That my family folder will comprise all the photos of my family. Solo folder will comprise of all the photos of mine only. So that is what I have decided. Okay. So I want to find out the anomaly in the credit card usage pattern. So that is also basically one kind of unsupervised learning. So one of the very popular unsupervised learning technique is a clustering. Okay. So in a clustering, ultimately my idea is to identify the hidden correlation, and possibly I want to also reduce the dimensionality. Okay. So here if you just observe that there are some points are there, there are some data points are there, but if I just observe the characteristic as a color, so according to the color, I can take them in a different group. Okay. So here possibly you just observed there is a three different group. Now this group I consider as a cluster. Okay. And in a particular cluster, if you just observe that all the members are from a same characteristic. Okay. So if I consider a red as a characteristic, that in a cluster you just observe that all the red members are there. In a blue group, you have all the blue member, and similarly as a green. So this is also another example of the clustering, where on the left hand side you just consider that there is a data which is input is given. Now here I am considering a feature as a shape. Okay, so I want to cluster that as a shape. Okay, so I have identified that there are three different shapes are there. Okay, so there is a round shape, there is a diamond shape, and there is a cubic shape. Okay, so I put them in a one particular cluster. So in a cluster, first cluster, you just see that all are with the round shape member are available. And in a second cluster, you have a means all the diamond shape, and the third all the cube. Now, when you observe a particular cluster, then in that particular cluster, all the members have a similar characteristic. That means the shape is similar. Okay. Why? If I observe a member of a one cluster with the member of the another cluster, then there is a dissimilarity or there is a difference among them. Okay. So that way I will apply the clustering, and that is a unsupervised learning approach. Now another very interesting machine learning approach is a reinforcement learning. Now what do you mean by reinforcement learning? Okay. So in the reinforcement learning, the entity is called as the agent, where agent is interact with the environment. Okay. And what is the result of the interaction? Okay. And then it will observe that what kind of reward he is getting. Now, according to the reward, he will keep that practice, or maybe he will throw out. So let me give you a simple example. Okay. So if let's consider that I want to become a cricketer. Okay. And I want to become a batsman. Okay. Now, if I want to become a batsman, then there is the one practice that maybe I can go to a coaching staff where there are a dedicated coach who will let me know that how I should approach each individual ball. Okay, and how I can become a better batsman. But that is the supervisor, because somebody is there who teaches me that how I need to react to a particular ball to become a cricketer. But there is another way also. Okay, what I can do that I can see a people who are playing a cricket. Maybe I can see at my street while kids are playing, or people are playing a cricket, or maybe I can watch a cricket and I will observe the things. Okay. Here I will observe the things. So here me I consider as a agent, What is the environment? The environment, maybe watching a cricket match on a television, or maybe watching a player to play a cricket at my street. So this is the environment. So me as an agent, I'm interacting with the environment and I'm observing the thing. Now, according to the observation, I will take something. Okay. So it is something like that. I am means watching a cricket match where I have seen the Rohit Sharma. Now, Rohit Sharma is very good as a pull shot. Okay. So I will adapt those things. Now, when I play cricket by myself, then I will also adapt those practice. Okay. But it could be a case that whenever there is a bouncer is there where I try to play a pull shot, but I am getting out. Okay. So that is not working for me. So that is not giving a reward for me. I will observe the reward. So if I can able to match whatever I have seen, then I will keep that reward. But if it is not working with it, then I will adapt the another practice for them. Okay. So that is the way that the reinforcement learning works. So basically reinforcement learning is very good at gaming. Okay. So possibly that is there. What is important in a reinforcement learning? There is the environment, there is the agent. So agent and environment is interacting with each other. So agent will do some sort of action, okay, according to the whatever the environment that we have seen, and it expects that there is the reward. Okay. So if the reward is positive, I will keep those reward and I will consider that I am learning out of it. But that is not working, then I will again change my style. I will again observe the things. I will try to adapt the another actions and again I will observe the reward. So I will keep on observing the environment. I will keep on changing the action till I satisfy with my reward. Okay, and that is nothing but the reinforcement learning. So reinforcement learning is basically means, as I said, that it may be used for the game playing, for the credit assignment problem, robotic application. So all these are reinforcement learning. Okay. So stands for the machine learning in general, if I say that. And data collection is a very important. Okay. So normally the database is available, but if at all, if you are interested to go for a data collection, then there are sensors are there through which you can collect the data. Then you do a data pre-processing. In a data pre-processing, we have seen that we will handle the missing value. Maybe there is an outlier that we want to remove it. We need to ensure that all the values are numeric. So that is nothing but a data pre-processing that I consider. Okay. Sometimes the data is imbalanced, then I will do a data balance. That is also considered to be a pre-processing step. Okay. Then I will go for a feature engineering. I will identify the feature according to my application, that what are the features that I need to consider so that I can solve my machine learning problem. So then finally I will adapt a particular algorithm which is suited for my machine learning. Now it could be your supervised learning when I can think about the classification, I can think about the regression, or maybe I can have a unsupervised learning when I can go for a clustering. So you know what is the difference. Okay. And then finally I will go for some sort of prediction or outcome. So data learning and a machine learning technique, what we have seen, that is the three important one. We need to understand the difference. Regression for a continuous data prediction in a supervised learning. Classification for a discrete data prediction, supervised learning. Clustering is an unsupervised, where I don't have a labeled data along with me. So what I will do, I will observe the data, I will observe the feature, and according to the feature, I will stick my decision. Okay. And that is nothing but the clustering technique. So classification and clustering, that difference is also already discussed. Classification and regression, that is also being discussed. Okay. Clustering and association. Association is something which I associate that with. Okay. It is something like that if that association is according to my practice or according to my observation. So it is something like that if there is a water leakage problem at my home, then I know that I need to call a plumber because I have observed that similar thing when it happened to my friend or maybe at somewhere else. So that is some sort of association. Okay. Association approach is seldom used nowadays. Okay. So this is all about the algorithm that possibly we have discussed and we are going to discuss. Okay. Then finally, I will just introduce a deep learning. So deep learning is a neural network based approach, okay, where we want to map a input output characteristic through some sort of hidden layer. Okay, so here you have an input layer, and there is some sort of hidden layer, and then you have an output layer. Okay, so through a stage wise process, you are trying to adapt it. So in a deep learning, basically neural network is a basic element. Okay. Now, what is the difference between machine learning and deep learning? So through a pictorial representation, you just observed it. When I talk about the machine learning, then there is a separate process of the feature extraction, and then I will do a classification. So here in a machine learning, the manually I used to extract the feature. Okay, so feature engineering is very important in a machine learning, where I extract the feature, then I will do a some sort of classification, and then possibly I will observe my output. But in a deep learning, when I say that in a deep learning, this feature extraction and classification both are unknown to me. So it is something like a black box. Okay, I have provided the data, I have provided the your let's say that output, and then machine will try to understand the pattern, which is not visible to me. Okay, so I am not doing a manually feature extraction. Feature is being extracted, that is hidden to me, and then it is being classified. And for me, what is important that how I can get the prediction. So for me, the how I can get the prediction. Now, machine how he has done that is black box for me. Okay, so that we consider as a deep learning. Okay, so deep learning in ML we have talked about. So there are various applications extensively. Some of them we are discussing. Image classification definitely in one of the lecture we will be discussing. Speech recognition is there. Language translation is there. Stock exchange prediction, biomedical and diagnosis system. So many applications that we are going to discuss: vehicular communication, face detection, and the video surveillance. So all are the applications. Okay. So with this, we are ending up our basic introduction of the machine learning session. Okay. Now I will jump to another is your Python programming. Okay. So now for a Python programming, if all of you want to practice with me, then possibly you can do it. I will definitely help you out. Okay. So maybe means you can do a practice along with me. Okay. So what is Python? Okay. So in a Python, basically a language we basically use for a data interpretation or data analysis purpose through a machine learning. Okay. So Google Colab is you can consider one of the application where you can run your Python script. Okay. So Google Colab is a free cloud-based service. Okay, where you can open the Jupyter notebook environment. So notebook is nothing but you can consider a file where you can write down your code. Okay, so it allows user to write and execute the Python code through a browser especially suited for a machine learning and a data analysis. So it is a very good environment where you can work on. So we will see today. Okay, so how Jupyter will looks like. So if you want to open a Google Colab, okay, then you can simply type out the Google Colab, okay, and open that Google Colab window so that you can do a practice with it. Okay, so type on Google Colab. Okay, it will looks like this. Okay, and here you will observe a drive. Okay, so you can open that drive. Normally sample.data folder will be there where some sample data is being available with you. Okay, so this is how it looks like. Okay, so means when you click on drive, then possibly it will ask you to connect with your Google Drive. You can connect your Google Drive like this, or maybe there is a command also to do the similar thing. Okay, you can directly click on drive and through which you can connect, or maybe there is a command that google.colab import drive and drive.mount and in a square bracket content drive. So through these two commands also you can able to open the Google Colab. So I am just trying to now open that file. Okay, just a minute. I have just stopped the screen. I am just opening that particular file so that Okay. So when you open the Google Colab, then you will able to see a file like this. I hope my screen is visible. Okay. So means I will be uh, discussing some basic command, and then possibly we will go to some sort of data visualization and interpretation, because there could be a case that somebody is newer for a Python itself. So with that, with consideration of that, I have prepared this particular lecture. Okay, so possibly you can go to a file, okay, and new notebook in a drive. You can go to a file and new notebook in a drive. If you have already one particular file, then you can go for open notebook, or maybe if you want to upload some notebook, then also you can do it. Okay, so currently possibly you can go for a new notebook in a drive. Okay, then so first we will see a data types in a Python. Okay, so how you can actually write down a simple command where there is some data types is there, how you can do it in a Python. Okay, so here I am taking a data type like a is equal to 10, so that is an integer. So a is 10, b is 3.4, c is a string that I have considered hello, d is equal to, you can consider one particular list I am preparing, 1, 2, 3, there are 3 members, and e is I have prepared a dictionary. Okay, just to showcase the different data types. So E is a dictionary. Okay, so A is 10. So if I want to just observe the data type, so what I can write out? The print is a command through which you can print the value. Okay, so print type, and in a round bracket there is a A. Okay, so A is 10. So when I just run this, okay, so when I run this, then you will observe that there is a class which is integer. So A is 10, and that is being identified that it is an integer. Then B is 3.14. So if I type print and in a round bracket type B, so what did we consider? That it is a float value. Okay. So similar C is a hello, it is a string. So when I try to print a type of C, then it will show as a string. Then D is a list. So when I just print it, it will show as a list, D as a list, and E is a dictionary. Now, second is we will think about some sort of arithmetic operation. Okay, so how the arithmetic operation can be performed in a Python. So here I have considered a one variable x, which is a 10, and y is equal to 3. So x is 10 and y is 3. So you just type it and then just observe it. Then the command is print x plus y. So I am direct printing the value of x plus y, or you can do that like you can consider one variable as a is equal to x plus y, and then you can print a. Then also it is possible, or directly you can write down print in your round bracket x plus y. So x is 10, y is 3. So when you just try to print it, then addition is 13, then will be printed. Similarly, print x minus y. So x is 10, y is 3, so it will be print 7. Similarly, x into y, so that is 10 into 3, 30. Then x divided by y. So x is 10, y is 3, so 10 by 3, it is 3.333. Then x 2 times x slash y. Okay, so this is again a division, but here through a division you will get a flooring. So it is just nothing but a floor of your division. So if you divide 10 by 3, then it is 3.33. But if you just do a flooring of 3.33, then you will get only integer 3. Okay, so flooring means always your down value that you will get it. Okay, so 3.33. So out of that, the integer value is 3, which will be printed. Okay, so x modulus y, so 10 modulus 3, so that means you will divide 10 by 3. So 3 into 3, 9, and the 1 is a remainder. So that remainder will be printed over here. So that is 10 modulus 3 is a 1. Then x star star y. So that is defining a power. That is the exponent function. So x exponent to y. So that basically you can read it. Okay. So x is 3 and exponent term, x is 10 and exponent term is 3. So 10 raised to 3. So you will get a 1000. Okay. Then we will see a simple comparison operator. So how you can compare the different value. So comparison operators are A is equal to 5, B is equal to 10. I hope that you are also doing with me. If you want to slow it down, then I can slow it down little bit. But if you want to write it down along with me, please write it down. Or maybe I can also help you out. So I am just also opening a new one. Okay. And then I will copy paste so that you can also do with me. Okay. So I am writing, let's say, so opening it will take some time. Yeah. So I am taking A is equal to 10. Sorry. A is equal to 10. Okay. And B is equal to, sorry, A is equal to 5 and B is equal to 10. A is equal to 5 and B is equal to 10. Okay. Currently, I am just running it. However, I have not printed, so you will not able to get any value. But let's take that I am talking about printing A equal to by B. Okay. So now we will run it. Print A equal to B. Okay. So it is false. Okay. So it is a comparison. So A is 5, B is 10. So that's why the comparison output is false. Okay. Then there is a print A not equal to B. Just simply copying. So that is not equal to operation. So again, you can plus the code, write down and run the code. So A is not equal to B. So A equal to B is false. A not equal to B is true because it is not equal to. Okay. Then I will do print A equal to, print A greater than B. Just run it. So that is false because A is 5, B is 10. So A greater than B is means false, and print A less than B. A less than B. So that is true because A is 5 and B is 10. Okay. And maybe last two I can execute parallelly. So A greater or equal to B, that is false because A is 5 and B is 10, and A less or equal to B, that is true. So that basically comes out as a true. Okay. Logical operator. Okay. So logical operator is nothing but basically it works on a Boolean value. So that is a 0, 1. Okay. So that's what I'm trying to do it, copy it over here. Copy it over here. So here X is true, Y is false. So X is 1, consider Y is 0. So print X, A and Y. So when I end in 1 with 0, then definitely outcome will be 0. So that is false. And when I do or it X or Y, so 1 or with 0, so definitely outcome is 1. And print not of X. So that is X is true, so outcome will be false. So this is it. So first one is X and Y, that is a false. X or Y, that is true. And not of X is false. Then your assignment operator, which are to be used to assign the value. So that I am just trying to explain it over here. Okay. So X is equal to 5. So that is just an assignment. Then second is X plus or minus 3. So that you need to interpret, that is X equal to X plus 3. Okay. So X plus or minus 3, that is a short way to write it down. But what you need to interpret, interpretation is X equal to X plus 3. So x is 5. So when I do x plus 3, then answer should be 8. Okay. So similarly, if you do x minus or equal to 2, so that is nothing but x equal to x minus 2. Okay. So you will get 6. Okay. So let's print at every point. Okay. So I have not printed it, but possibly you can write it down. Print x so that you will able to see the output. So that is 5 plus 3, it is 8. Okay. Let's print it over here. So x minus or equal to 2. So that is nothing but the interpretation of x equal to x minus 2. So x is currently 8. So 8 minus 2. So that is outcome will be 6. Okay. Similarly, let's put it over here. X multiply equal to 4. So x equal to x into 4. So that star is nothing but the multiplication. Okay. So currently x is 4. So if I multiply it with the, sorry, currently x is 6. And if I multiply it with the 4, then 6 into 4, the outcome will be 24. So that's what it's come. Maybe I can put it over here. So that is x equal to x divided by 6. Okay. So that is the division. So currently x is 24. And while I divide it by 6, then my answer will be 4. Okay. Then x modulo 5. So x equal to x modulo 5. So ultimately my x is currently 24 and I divide it with the 5. So it is 5 into 4, 20. So 24 minus 20. So the remainder will be 4. That remainder 4 will be printed over here. Let's run it. So you will be able to visualize it. 4. Okay. Then x equal to x raised to 2. That is star 2 times. That is nothing but your exponent operator. Okay. So currently x is 4. And when I put exponent 2 of 4, then it is 16. Right? Possibly you will observe it. Then x equal to x floor of, so I will divide x by 3 and then whatever the flooring value that I will consider. So currently x is 16. So if I divide 16 by 3, then ideally I will get it around 5.33. Okay. But since I am using a 2 time backslash, so that will automatically do a flooring. So I will get the outcome as a 1. Okay. So this is all about the assignment operator which we have. Then there is a bitwise operation also. You can do it in your Python. How you can do it? Ultimately, you need to convert that value into binary. Okay. So what you can do that? Just try to do it with me. So A is equal to 6 and B is equal to 3. So 6 is nothing but 110. Okay, because when you do any kind of operation, that is you want to do bitwise. Okay, so this is bitwise operator. Okay, so since it is a bitwise operator, so you need to convert that whatever the value that is being represented here. The integer value 6 is there. So 6 equivalent binary is nothing but a 110 and B is equal to 3. So that is 0, 1, 1. Okay, so that means that 110 and 0, 1, 1. So in binary, you will get it this. So A and B. So binary 110 when it is ending with 0, 1, 1 and that is a bitwise. You just observe that 0 LSP with 1. So outcome is 0. So middle value is 1, 1. So you will get a 1 as the outcome and 1, 0 is 0. So this is simply 1, 1, 0, 0, 1, 1, 0. If I do bitwise ending, then it is 0, 1, 0. So outcome is 2. Okay. And this is OR operator. This 5 is nothing but the OR operator. Again, bitwise operation, then 1 OR with 0, that is 1. 1 OR with 1, 1 and 0 OR with 1, 1. So it is 1, 1, 1. So you will get output as a 7. A XOR B. So this operator is nothing but for XOR. Okay. So A is 110 and B is 011. Again, if you do a XORing, then you will get 101. Print negate A. Okay, so that is somewhat interesting. Okay. So here, what it will do? This is integer. Integer will be always in a 32 bit. Okay, so what it will do here, what it will do, explain in a new slide. What will happen over here? So when I consider A is equal to 6, so ultimately 6 is being represented like 110. Am I right? Yeah, 110. And in front of that, since the value is positive, you have a 1111. So that is the 32 one. Okay. But when I do not, okay, bitwise not. So what will happen that this becomes this one. 0 becomes 1, 1 becomes 0, 0 becomes 1 becomes 0. Then I have a in front of this 1. Okay. So this value, whatever is basically -7. How you will read it? 100. So 1001. So if you just observe it, this is actually -8. Okay. And this is 1. Okay. Sorry. This was a positive. So this has to be 0. That was my mistake. So this was 0. So that becomes 1. Okay. So now this is, and along with that 1 because it is a side extension value. Okay. So it is side extension value. So you have all remaining 1 to fill up my 32 place. So here if I read it, then it is 101. Okay. So 101 when I read it, then this is -7. Okay. So that's what you will get as the output. Then A left shift. So A left shift 1. So your this 110 becomes 1100. Okay, so that you will read as at 12. Then A right shift 1. So that means 110. If I shift it one time, then it becomes 011. Okay, so that is the output. So you just observe it. The output will be for the first where I do a bitwise ending is a 2. Then bitwise ORing is a 7. Then A XOR B is 5. Then not of A is -7. Then A left shift 1, that is nothing but the 12. Then A greater or equal to 2. So left shift is nothing but if left is nothing but shifting left is nothing but multiplying by 2. So 6 becomes 12. And when I say right shift, that right shift is nothing but basically division by 2. So if original value is 6, then definitely divide by 2 is 3. So that's what you can interpret like this. Okay. So that is the bitwise operation. Now there is a membership operation. Okay. So here we will create a one list and we will observe that whether a particular one is a member or not. Okay. So let's take one example and run the code. So I am taking a one particular list and name that list as a fruits. So fruits equal to first member is an apple. So inside the list, when I want to define a member as a string, okay, because this is a string. So string is always in this kind of double comma. Okay. So when you write down something in a double comma, then that data type is considered as a string. Okay. So here the first member of that particular list string type as an apple, and second member of this particular is a banana. So I will write down print apple in fruit. So what I am trying to do, I am trying to find whether a apple string is a member of this particular list or not. So there is a fruit list we have created. Okay. And I am trying to find out whether a apple is a part of this list or not. So since apple is a part of the list, then you will get the outcome as a another is print mango not in a fruits. Okay. So here it will find out that mango is not in a fruit list. So that means the mango should not be in a list. So since the mango is not the part of the list, so say again the outcome is true. So if I run it, so you will get the true. So first two is just to observe that apple is the part of the list. Okay. So that for that is the true. And second is mango is not part of the list. So since the mango is not part of your list, so you will get a true here as well. Okay. So that is a membership function. Another is just to have a control with the loop. Okay. So if else that we are going to see it. So just try to copy this particular code and just try to run it over here. I hope you are also doing with me. Okay. So here I am typing x equal to 10. So x I am taking as a one variable where I am assigning the integer value 10. So x equal to 10. Now in a second, what I am trying to do, if x is greater than 0, so currently x is 10. So 10 is greater than 0. So definitely it will print positive. Else if x equal to 0, then it will print 0. Else if print is the negative. Okay. Just try to run it. So x is 10. So definitely means outcome is positive. But if I make x equal to 0 and run it, then you just observe that it will print 0. If I put x equal to minus 10, then definitely it will print as a negative. Okay. So this way you can write down a control loop. So here it is a nested if. So you can have a multiple condition. Okay. So if x, there is a condition, else there is a condition, and there is a else is a third condition. Okay. And loop control. In a loop control, you can have a break, continue, pass. All these are possible. Let's consider that first case where we use a break inside this. So what I have written for I in a range of 5. So I will start by default 0. So 0, 1, 2, 3, 4, 5. It will increase. If I equal to 3, it will break. So it will start with the 0. It will go to 1. It will go to 2. And when it goes to 3, then it will matches this condition with the if. So I is equal to 3. It will matches this. So when it is matches, then what you do? You need to break this particular loop. So it will reach 0, 1, 2 only. Because when it reaches 3, then you have considered that it will break. So this is the break. Similarly, you can have a continue. So this is totally opposite. Okay. So here it will start with the I is equal to 0. So when I write it down, then it will start with the 0 only. So I starting with the 0 to a range 5 to 0, 1, 2, 3, 4 like that. So it will go up to total 5 values. So you are starting with the 0. That means it will go to n minus 1. So 0, 1, 2, 3, 4 like that. Okay. But when it is 2, then it will continue. So that means it will skip that. Okay. So the value will be printed in 0, 1, 3, 4. So when I equal to 2, when you write down continue, then it will skip that particular one. Okay. Then there is a way to write down a placeholder. It is a pass. Okay. So for I in range 5, if I equal to then pass, that is a placeholder. Now what is the meaning of having a placeholder? That you will write down something over here in future, but you do not want to write down over here. So for that you write down simply pass. Okay. So that means for I equal to 2, there is something which I want to write it down, but currently I am not writing. Okay. So this is the placeholder. So in future I will come back over here and I will complete. But currently I just want to move ahead with the another. Okay. So that's why I have used it pass over here. Okay. Then loop with the else statement. This is a simple if else statement dot what we used to have it in our C and other language. Okay, just run it. So for I in a range 5, print type else print loop finish. So it will start with the 0, 0, 1, 2, 3, 4. And when it reaches to 5, then it will go to a else condition. And What else it will print the loop finish without break. Okay. So this is a simple loop structure that is available in this. So now possibly we will do a slightly higher level of a data type in a Python. So next is the array. Now how you can define an array over here. Okay. So let's take this and type it over here. So here I am defining a array. Okay. Array is equal to 10, 20, 30, 40. Okay. Now when I say array, then usually in an array I will put an integer value. Okay. List is something where I can provide a string as well as, if possible, integer value. But when I say array, then array is nothing but having a same data type, and usually I will use an integer. Okay. So here array is equal to 10, 20, 30, 40. So print array 0. So now array. Now if I want to identify the member of array, then the indexing starts for 0. Okay. So when I say 0, then it is point out to a first value. Then it will go to a second value as of 1. Indexing is 1. Then second, indexing second means the third member. Then fourth member, that is indexing 3. So here what I have done, print array 0. So with this indexing, it will point out to a first value. So print array 10. Okay. So here it will print 10. Then array of 1, 25. So that means I am replacing the first value is a 25. So 0 is 10. This 20 is my first value. So I am writing array 1, 25. So I am just updating or replacing. Okay. So 20 now replace with the 25. And when I print the array, the new array is 10, 25, 30, 40. Okay. So this way you can do array, and there is some functionality of the array is also being imbibed. The array module provides the C-like array structure of the element. Okay. So that also we will see that we can import the array and then we can do some sort of functionality. Just we will try to do it over here. Okay. So here I am importing array. Import is nothing but I am importing some library and I am recognizing this as a ARR. So that means I will consider now this importing library array as a ARR. So when I use the ARR, then it is pointing out that array only. Okay. So it is something like a similar name. Okay. So array is now, so it is something like that everyone has a pet name. Okay. So we do have a pet name. Okay. Like one name through which we recognize, but pet name is just for our local home people. So similarly, when I write import array as ARR, and that ARR you consider as a pet name, but that pet name is pointing out to a same as an array. Okay. So A is equal to ARR dot array. That is I 1, 2, 3, 4. So that is basically it will create an array. Okay. The value will be stored into a A. So when I print it, then simply it will print the value of A. Okay. So it is just nothing but the array, and array is nothing but I 1, 2, 3, 4. So whatever is being written in the array, that will be print when I print A over here. Then A dot append 6. So what it will do? When I use the function append, then it will put the value at the last. Okay. So after whatever the last member is there, it will add that value. Okay. So value will be added at the last when I use the append function. So A dot append. So 6. What is that value? 6. Now where it will be appended? Appended at the last. Okay. So here if you just observe that initially array is 1, 2, 3, 4, 5, but this 6 is being added because I have used this A dot append, and with the print now it will be printing. Okay. Then print A2. What is the 2? Dekho. I is a 0th member, 1 is a first member, and 2 is a indexing 2, that means third member, because we are starting with the 0. Okay. So member will be n, but indexing starting with the 0, so it will go up to n minus 1. So when I write it down, A of the 2, then ultimately I am pointing for a third member. Sorry. But here, this function is basically works for a list. Okay, so that's why here in this particular list or array, this is the third member. So that's why it is pointing out the answer over here. Sorry, numpy. Okay, so here there is a function as a numpy that I am using. That is also one of the library that we have in our Python. So I am just writing it. So import numpy is a library as np. So again I am defining it as an np. So a is equal to np dot array. So inside that numpy there is a function array. So now there is a library, and inside that library there are multiple functions. Okay, so when I use np, then I am pointing out to a library numpy, and inside that numpy library I am accessing the function dot array. So np dot array, then it is 1, 2, 3, 4. So I am creating a numpy array over here. Okay, then I will print a. So it will print all this value. Then print a into 2. So that what it will do, whatever the member of a, it will multiply with 2. Okay, so to all the member of array a, it will be multiplied with 2. So here a is nothing but 1, 2, 3, 4, and print a into 2. That means each member will be multiplied by 2. So 1 becomes 2, 2 becomes 4, like that 5 becomes 10. Okay, so this is all about the numpy array. Now numpy operation. So what I am doing it over here, import again a numpy library, which I am defining as a np. Okay, so numpy library is being imported, and I am defining it as np. So a is equal to np, that is nothing but numpy dot array. Now I am creating an array where it is 10, 20, 30, 40, 50. So these are the member of my array. So total 5 member is there. Then I will try to print a. So print a will nothing but will fetch me this value 10, 20, 30, 40. Then print a0. Print a0. What it will do? It will print the first member. Okay, so just I am trying to run it over here. So 10, 20, 30, 40. Then there is the first member. So here the first member is 10. That's what is being printed over here. Okay, so print a0. So that is nothing but the first element. A1 is equal to 25. That is nothing but I am updating the value or replacing the value. So now if I print a, then this 20 will be replaced by 25. So that's what it is being done. Then print a dot size. So size is also an inbuilt function which is available in a numpy. Okay. So when I write down print a dot size, then it will print the size of a. So here if you just observe the array is having a 5 value, 10, then 25, 30, 40, and 50. So that size of the array is 5. So that is being printed over here. Just observe this is 5. Okay. And print a dot save. Okay. Now it will basically define that how in terms of the matrix it will look like. Okay. So a dot set. So this is nothing but you consider a row. Okay. So in a row you have 5 elements. So this is a row matrix. There is no column. Okay. So this is defined as a 5. Okay. Then to just means explain in better way, I have taken another example. Array 2 is equal to np dot array, and then you just observe 1, 2, 3, and 4, 5, 6. So it will create a 2D array. Okay, here is a 2D array. Now if you just observe the shape, then what will be the shape? Because you have a 2 row and 3 column. So it will be printed as a 2, 3. Okay, because it has a 2 row and 3 column. Okay, so that's what it will print over here, 2, 3. Okay. Then print a dot d type. So it will print the data type. So a is an array. Now always in an array, all the value of having a similar data type. So that you please consider. Okay, when you have an array, then all the data type is a similar. So that's why this function is valid. A dot d type. So that means it will find out the data type of all the member. And since all the member is having a similar data type, so it will print out as a integer 64. Okay. So print A1 to 4. So here I am slicing it. So A is having a 5 member, but I am slicing it to 1 to 4. So that value, if you just observe it, and slicing value will be 25, 30, 40, because 0 is not included. Okay, if I consider 0 to 4, then it will print the whole array. But I am slicing it 1, 2, 3, 4. So that's why it is printing only up to, actually there is no fourth member. Okay, so it is 1, 2, 3 only. So that's why it will print 25, 30, 40. If you have a appended last value, then possibly it will print the fourth value as well. That is the fifth member. Okay, then print A into 2. So that we have seen it. It will multiply with the 2. Then print NP, that is the numpy dot square root of A. Okay, so what it will do, whatever the A is there, it will print the square root of A. So A is nothing but 10, 20, 30, 40, 50. And if I put a square root, then the square root of 10 is nothing but the 3.16 something. Then if I do a square root of 20, then their value is something like a 4. Okay, so that square root value will be printed over here. Okay, then print np dot sum A. Okay, now we are actually moving towards the statistical. So what it will do? NP. Okay, so numpy where I am using the sum. So sum is also inbuilt function. See, since I am using the imported the library numpy, so now I am eligible to use all these functions. So this function is available. So np dot sum of whom A. So A array में जो भी element है उसका sum करना है. So that will it will do a summation of 10, then you have a 25 because we have replaced it over here. Okay, so it is 10, 25, 30, 40, 50. So it will do a summation of all and it will add up the value as a 155. Then print np dot mean A. So what it will do? It will find out the mean. So 155 is the sum divided by 5 member. Okay, so it is nothing but a simple average. So summation is 155 and divided by 5. So it will do a average. And it will find out the maximum value. So max A, mean A, similar way it will do it. Okay, then you can do some sort of means concatenation also. So np dot concat xy. So here I have defined one array x, I have defined one array y. And if I do x and y, then it will concatenation nothing but the joining. So it will joining these two values. So that means when I print this, then it will print 1, 2, 3, 4, 5, 6. Okay. You can have a stack value also. So stack value means one after another. So it will print the first row and then it will print the second row. So that way also you can able to visualize it. So this is about all about the numpy. Then there is a way to define a function over here. Okay, so let's do it and run it over here. Okay, so I am defining a function def is nothing but the defining the way of the function. So grid is a function name. So def is nothing but a function, and I am redefining the function name as a grid. And what is being printed inside this particular function? Print hello, welcome to Python. Now I am just calling this function grid. So grid is being called, which is a function. So inside that, what is that? So it will be printed. Then I am defining another function where I am defining the function name is add, where I am passing two variables a and b. And what is there inside that function? I am returning the value a plus b. So whenever this particular function is being called, then what it will do? It will add the value of a and b what is being passed to. So this is what we have done it. Print sum, then add function. Here I am calling this function add function. So add is being calling, and the two argument I am passing. So a is nothing but 5 and b is nothing but 3. So what it will do? It will go inside the function and it will return the value of a plus b. So 5 plus 3. So it will return So here the first greet function is being called. So for that, hello, welcome to Python is being printed. And that is another function, add is there. So add where I am adding the value a plus b over here. Okay. So there is a lambda. Lambda is nothing but when you write down a function in a single line itself. Okay. So we use seldomly over here, but this lambda is also available in your where you write down whatever you want to write down inside the function, but that you write down in a whole line itself. Okay. So what it will do here is a square lambda x. So it will return the value of x. So x is a value which holds the output. And what is the functionality? X into x. Okay. So when I write down print square 5, so square where x is being passed as a 5, so 5 into 5. So that is nothing but the 25 will be printed over here. Okay. So lambda is nothing but the way to write down the function in a one line itself. Okay. Then class and object. Okay. So there is a way that you can write down a class and object over here inside the Python. So let's try to see it over here. So here I am defining a one particular class as a student, and then I am defining DEF, and then DEF is nothing but the function, and inside it INIT. So this is the way that I am creating a construction. What is a constructor? Constructor is nothing but creating something and creating a space for that, and I can use that as a handle later on. Okay. So def is a function, then I am defining inside that self. Self is the argument that you always need to write it down. Okay. And then there is a name and age. Now when I use self.name, then it will consider the name of this local construction name. So inside this function, whatever the name is that I'm using. Okay. So self.name is nothing but the name of this particular. So it is something like that. The name one I can use for another. Okay. So that is a local variable that I am defining over here. So self.age is nothing but the age. So that is the self is nothing but the calling that function, and that function inside which I have a name. Okay. So name is nothing but assign as a name. There is a local, and similarly self.age is age. INIT is recognized nothing but a one constructor. What is the constructor? Constructor is nothing but that through which we can use a handle. Okay. So the constructor concept is nothing but the concept of the C++. Okay. So in a C++, we first create a constructor, and through a constructor we create a handle, and we use that particular variable which is there inside the function. Okay. So whenever I want to use any particular thing inside this particular function, then I can use that through a handle only. So that is basically C++ concept. Okay. So in a C++, it is a protected language. Okay. So when I say it is a protected language, then whenever I want to use something which is there inside this particular class, then I can use that through a handle only. And when I want to use through a handle, then I need to first create a constructor. Okay. So through a constructor creator, I will use the handle and I will use that particular variable. Okay. So that is what is being defined over here. And there is another function def, which is basically defining as a display. Then I am creating a list name, self.name, age, self.age. Okay. So here I am defining S1 is equal to a student, where I am defining Alice and 21. So that is nothing but creating a one particular object as a student, which I am defining as a S1, where I am defining Alice as a 21, and creating another object of the student Bob, and age is 22. So when I just simply run it, so it will define that S1.display. So this will be display and this will be display. Okay. So here I will use a display. Display command is when I want to display object, print through which whatever I will write down, that is nothing but the variable data type. That, but here I wanted to print the value of the object. So that's why I will use S1.display. Okay. So whenever you want to do some operation of a printing with the object, then you will use this one. S1 dot display and S2 does. Okay. Dictionary. Okay, so there is a way that you can create a dictionary inside the Python. Okay, so let's create a dictionary and just observe the value. So student dictionary I am creating, and inside that name is a one variable where I am defining a alias. Okay, so inside the dictionary a name along in front of the name there is a alias is written. There is another age in front of this 21 is. So through this comma I am defining or I am separating the dictionary variable. Okay, or dictionary member. Okay, so first is a name where name is basically assigned to alias, and second is age is basically 21, and grade is age. So I am creating a dictionary, and in this dictionary you can consider three members is there. Okay, then I will print the student, so it will print the entire dictionary. Okay, this is the dictionary which is being created. Okay, now inside this dictionary I want to search something. Okay, so print student name. So inside the student dictionary, there is a name. Okay, and in front of the name, what is being written? That I want to print. Okay, because name is being actually printed in front of that alias. Okay, so when I point out name, then ultimately I am pointing out the alias. Okay, so when I print student name, then it will print the alias. Okay, then print student dot grade. So inside the dictionary student, I want to identify what is the grade. Okay, so get grade, so it will return the value. So it will point out to a grade, and in front of the grade, what is being written? It will return it over here to a get function. Okay, so student may, when I write down this, then definitely grade is A, and student age is 22. Now I am just updating it. So now how you can do? So see, I have initialized the dictionary with the student, but still if I want to replace or update, then there is a possibility that you can do it inside the dictionary. So here student age equal to 22, so that is being updated. So I am just updating the dictionary. So in front of the age, now I want to replace 21 with the 22. So student age 22 is being there. Now city is New York, that I am adding the new value. So that is where I can add the value and I can do that also. And I can simply now print the each member of the dictionary as well. Then there is a way that you can do a listing. So listing I can do, you can do it. You can do a tuples as well. So that is there. Pandas. Okay, so pandas is also one of the important library. Okay, when you are handling a data set. Okay, so while you are handling the data set, then possibly you use the library panda. Okay, so here I am writing import panda as a PD. Okay, and I am creating a data. Okay, name, again it is a dictionary name. Along with the name, what are the name I am printing? So now there are more members. Okay, so along the name there are three members. It is Elias, Bob, Charlie, then age 21, 22, 23, and grade A, B, A. Okay, and when I just print this DF, yes, what happened? I think somebody is asking, what is that question? Will you please send me Python tutorial? Yeah, I will send this code. There is no problem. Okay, I'm just explaining right now. Today itself, I will share the PPT. Okay, along with this particular Python script. Okay, so you can do it by yourself also. Okay, we will share all this. Okay, I will place this inside the WhatsApp group also once I upload all these documents. Okay, so there is no problem over here. Okay. All the related material will be shared, so don't worry about it. Okay, so this is the way that possibly I am writing it, and once I am running it, then you will observe something like this. Okay, in terms of the data. And possibly you can do importing the library also 1D array. Okay, possibly this one is important. How you can load the data. Okay, how you can load the data. Okay, over here. So again, import panda as a PD. Just I'm trying to do it over here. Okay. So import pandas as a PD. So whenever you want to load the data, and usually the data is in CSV file. Okay, usually it is in Excel. Okay, and that Excel extension is .csv. Okay, and when you want to read it, then how you can read it? Okay, so first of all, you need to use the library panda. So import panda as a PD. Then df is nothing but the variable for the data frame I am considering. PD is nothing but the panda, and inside the panda there is a function read underscore CSV. So read underscore CSV is a file through which I can read a CSV file, and then I need to define the location. Now here, if you just observe it, there is a sample data is there, and there is a mint.csv file is there. Okay, so here you can just copy part and just paste it over here inside these two inverted comma. Okay, so that copy part will be over here. So ultimately here in a drive, I have a sample data folder. Inside that sample data folder, mnist underscore dot test CSV. So you just need to go to this CSV file, and since you want to read this, you just copy part and place it over here. Okay, then you will be able to read this in .csv file. Again, if you need to use this command, you need to use the panda library. Okay, then you are interested to print first 5 rows. It will print first 5 rows, and if you want to print only header, then it will print only the header. So header is having 5. So here there is a data file which is there, which you can actually read it. Okay, so that data file is already there. I think this sample.data is usually when you load the drive, it will be available. Okay, there is some sample file is there. By default is available. Okay, so that is available, and then I am reading it over here. Okay, now next thing is how you can go for a data visualization. So data visualization is very important over here. Okay, that how you can interpret the data. Okay, so usually data is there in your Excel format. There is a database is there in Excel format. Okay, or sometimes it is in EDIF format. There is a different format is also there. So that you can do. No, not via mail. I will share on Canvas. I have already shared the link on the Canvas during the confirmation mail. If you are not member, then please be a member. Okay. So please don't ask this kind of question currently. Okay. We will have a question answer session at the last. So at that time we will do it. Okay. So what I am talking about that the data is there, but now I want to represent that data in a better format. So data visualization is very important. Okay. So here, in order to do that, I will import the another library, that is the matplotlib library .pyplt as a PLT now. So inside this library pyplt, I am defining as a PLT. X is defined, Y is defined, then plt.plot. So it is X versus Y plot. Okay. So it is nothing but the representation of this X and Y. So this beautiful plot you will get. But along with the plot, I want to define a title. Okay. So maybe for the plot title, I will use the plt.title. So this title, whatever is there, simple line plot will be there. Then you will define the label to X and Y. So that is being defined over here. Okay. You just simply do it over here and run it. You will be able to get this particular output. Okay. So this way you can just able to visualize this. So this X and Y, I will define one particular array. Then I will just plotting X against Y to this particular plt.plot command. Then I am defining a labeling. Okay. So title of overall plot. Then what is my X? What is my Y? And that I am defining over. Then there is an important library which is a cbird. Okay. So cbird is basically useful for data visualization. Okay. So if I want to visualize my data in a better way, then there is a one inbuilt library, Python library, Seaborn. Okay. So Seaborn is a Python library based on a matplotlib that provides high-level function for creating attractive and informative graphics. So your graphical view could be looks like in a much better way or more understandable format. Okay. So for that, there is a Seaborn. Okay. So now for that, I am using a PIMA data set. So PIMA is a diabetic data set. Okay. So this data set contains the health record of 768 female patients from the PIMA India community. Okay. So this database is generated in a particular US state. Okay. Where 768 female samples are being collected. What it includes the pregnancies, whether a woman is pregnant or not, their glucose level, their blood pressure, their body mass index, their insulin, their age, and their diabetes outcome 0 or 1. Okay, so all these value there in this. It is commonly used the diabetes prediction library. Okay, for a data analytics. Okay, so this is the data set CSV. Just observe it. This is actually the data set. Okay, but when you actually download it and observe it in a better way, then possibly you will be able to see that. I think that I have downloaded it. Not downloaded yet, but means you can download this PIMA data set from a Google. On a Google, you just search PIMA Indian Diabetes CSV, you will able to download that CSV file. Okay, where you will observe one Excel over there. Okay, now inside this Excel, I want to plot something. Okay, so for that I will use a Seaborn function. Okay, so I want to have a scatter plot of the glucose versus BMI. Glucose versus BMI. Okay, so there are multiple features are there. Pregnancy is there, glucose level is there, blood pressure is there, BMI is there, insulin is there, age is there, and diabetic is there. What I want that I want to have a plot between glucose and BMI, between two particular features. I want to have a plot. And how I can do it. Okay. So that we will see it. Okay. But before that, how you can import it, just I'm trying to do it over here. Just write down the code. If you are doing with me, then here importing a Seaborn. Seaborn is nothing but for a data visualization tool. As I said that whatever the matplot is there, similar way, but Seaborn is a having a better visualization tool. So you can able to visualize it in a better way. Okay. While matplot library is having a similar some basic plotting functions are available. Okay. Then I am importing the pandas as a PD. Then I am loading the data set. Now here you can directly load the data set from URL. So I am writing URL and this is a URL. Okay. On this URL, if you just directly go and search it, you will be able to see the data set over here. Okay. This is the data set. Okay. That you will get it from this particular URL. Okay. So this PIMA data set and this PIMA data set, you can download it and you can visualize it. Okay. So here there is a column which is that pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, that is basically considering that genetic, whether the father, mother or grandfather is having or not. So that is considering a genetic history. Okay. However, we are not using it, but this column suggests this. Then age and outcome. Then I am defining DF is equal to PD. Again, read.csv URL. So I want to read this URL and names as a column. इस URL में इस column को मैं define कर रहा हूँ. So I am loading this CSV file from the URL और इस URL के column है उसको मैं name कर रहा हूँ कैसे pregnancy, glucose, blood, skin, thickness like that. Okay. So when you run it, then it will directly take out the code. Okay. And then it will visualize it like this. Possibly it is taking the time, but you will be able to see it. if you go load कर रहा है ना, it is taking time, and possibly I am using my laptop, not a high configuration system, so you will able to do it. Okay, then I am just going quickly because possibly we are running out of time. Okay, here what I am trying to do, I am trying to do a scatter plot. Okay, so this kind of data visualization is very good in a Seaborn. So I am using SNS, so that is the Seaborn scatterly plot. Okay, for data here, where I want to plot X as a glucose, Y as a BMI, and U is my outcome. Okay, so here X is the glucose, Y is the BMI, and your this data point is of basically outcome. So outcome is whether a patient is diabetic or not. Okay, so 0 means non-diabetic, 1 means diabetic. So here it is showing along with the glucose, what is the whether a patient is diabetic or non-diabetic, and this is the BMI index. Okay, so BMI versus glucose is there, where I am considering a data point is the outcome, and that outcome is nothing but 0 or 1. 0 outcome is nothing but the non-diabetic, and 1 is nothing but the diabetic. Okay, then you can go for a histogram. So histogram is nothing but the display of the distribution of a single continuous variable. So here I am defining the histogram of age versus count. Okay, कि इतनी एज में डायबिटीज हो रहा है, दैट मीन यहाँ पे बेसिकली जो डेटा पे वो 21 से स्टार्ट हो, ठीक है, और 21 से लेके शायद 80 तक का है. सो बेसिकली 21 में इतने काउंट है, 768 है, ठीक है, तो 768 में से तकरीबन आई थिंक मोर देन 200 is basically for a 21 count. Okay, when there is a 22 like that, so there is a count value which is being displayed over here. So automatically this will be find it out from your CSV file and it will be plotted over here. Okay, then you have a box plot. So box plot is nothing but the outcome, that is the diabetes for the glucose value. तो बॉक्स प्लॉट में क्या करेगा, वो आपका मिनिमम और मैक्सिमम वैल्यू का बीच में बॉक्स प्लॉट करेगा, ठीक है. तो यहाँ पर मिनिमम वैल्यू तकरीबन मेरे ख्याल से 80-90 के आसपास है और 120 पर, ठीक है. दैट इज फॉर अ जीरो, दैट मींस फॉर अ नॉन डायबिटिक. फॉर अ डायबिटिक you just observe that it is starting from around 120 and it will go up to the 170. Okay, so this box plot is nothing but the creating a box for that particular variable. That is for a zero, that is for a non-diabetic case. What is the minimum value? What is the maximum value? So it will create the box for that. And similarly for a 1, it will create the box for that. Heat map. Heat map is nothing but the correlation. So here we have a different variable. Okay, that total variable are outcome, age, so diabetic pedigree, BMI, insulin, skin thickness, blood glucose, pregnancy. So here X versus Y. So pregnancy versus pregnancy correlation is 1. But if a woman is pregnant, then what is the probability of having a glucose value higher? So that is being defined, blood pressure. So there is a correlation of the pregnancy variable along with the glucose. Okay, so that correlation is also you can plot it with this heat map function. Okay, so that is also possible over here. Here also that age group along with the count, you can get the plot of it. Okay, then there are the pairwise plot. Okay, so pairwise plot, that means you can get the pregnancy. So whatever is basically in a correlation. Okay, so here in the correlation, you use all these 9 variables along with the 9 variables. So X and Y, you have a same variable and you are finding the correlation. Okay, so definitely at the diagonal, you have an intersection. So that means the pregnancy against the pregnancy and glucose against glucose, you have a 1. But definitely the pregnancy with the relation of the glucose is 0.13. Pregnancy with the blood pressure 0.14. Okay, so that way this is the heat map, and that heat map is exactly being represented over here in terms of the plot. Okay, so there is a pair plot also you can do over here like this. Okay, so I will provide this code to you. Maybe you can just go through it, this particular file. Here in this particular file, I have tried it out, all the basic Python command along with the some of the basic plots that you can use it. Okay, so the code is with you. You just try to run this each line one by one and try to visualize the output. If you have any issue, then definitely means I will be available tomorrow 5 to 6. Possibly I will be available in further lectures also on Friday and the next week also. So you can ask me a question at any point of time if you have any doubt regarding a code which is being written over here. Okay, definitely most of the functionality, whatever is being covered inside this code, you will be using in a separate session. Okay, so there is a EEG hands-on session is there. There is a separate session for the ECG hands-on. So for that, you will be able to use all these functions. But in this lecture, basics of Python introduction, what my intention is to make all of them, all of you in a one single level. Okay, because many of you may be newborn for a Python script. Okay, so for them, I request them definitely you look at this particular file and try to run it and try to observe the command. If you are getting any problem in any of the command, please do let me know. We can discuss it. Okay. Even in a canvas also, there is a one section discussion. Okay, where we can have a discussion among ourselves. Okay, so that also you can use for the discussion point. So with this, I am stopping it over here. Maybe we have a 1 or 2 minutes more. So maybe we can have a quick question from your end if you have. Okay, but in this lecture, possibly I have gone little bit faster for a later stage just to ensure that to cover all these things, possibly in a 1 or 1.5 hour, whatever is given to. Yes, if you have a question, then do let me know. See, regarding the code and sharing all the materials, definitely I will do it by today itself. So don't worry for that. Any question? Management. We will get no issue. Okay. It seems to be there is no question. Okay. If you don't have any question right now, then we can stop it over here. See you tomorrow at 5 o'clock. We will have a classes for 5 to 8 only because in the polling means we got that result only. So we will stick to 5 8 to 8 only. Okay. So thank you for the joining and see you tomorrow again.